We're going to be talking about and answering two basic questions for this part of the discussion on the Columbia River Basalt Group. The first is, what are the primary rock types in this geologic province and how did they form? Well, the main and major rock type is, for obvious reasons, basalt. But the second rock type is andesite. And the way these formed was through 5 main episodes of large-scale volcanism that happened in the western Idaho, southern Washington, and northern Oregon regions. And they had, and this volcanism created a number of basalt flows that each have a different name after it to indicate the period. And the first was the Imnaha basalt, and which was followed by the Picture George basalt, the Grand Ronde basalt, the Wanapum basalt, and the Saddle Mountain basalt. And through a large series of these basalt flows, they created the Columbia River Basalt Group that is before you. The second question we're going to answer is, what are the primary ages of the rock groups in this geological province, and what are those ages based upon? Well, most geologists put the eruptive activity that created these basalt flows at 11 million year period from 17 million to 6 million years ago, roughly. And they also believe that they took place mostly through a 2.5 million year time frame. That's when most of them were occurred, and those happened during the Miocene era. And the way they figured that out was through radiometric dating and stratigraphy and magnetostratigraphy. Thank you.
We're looking at the current geology of the Columbia River basalts. There are many lakes on the basalts. These lakes formed when rivers dammed up due to drainage pattern change on the entire plateau. A great example is Clarica Lake, found in western Idaho. Pillow lavas are also commonly found. Pillow lavas are named that because they resemble pillows. Also, pillow lavas only happen when volcanic eruptions happen underwater. Hyaloclastites are also found with pillow lava. Hyaloclastites are tuff like breccia, which form underwater as well. There are also many dikes within the Columbia River basalts. Dikes are rocks that formed in cracks of pre-existing rocks. In the basalts, they trend in a north-northwest to south-southeastern pattern across Oregon and western Idaho. There are also many fissure vents found. Fissure vents are linear volcanic vents opposed to the typical idea of a volcano, such as this one that tends to be a cone shape. There are also many lava deltas. Lava deltas occur when a lava flow enters a standing body of water, and when it does so, it breaks up into small pieces and lands on the bed of the water. Next is the topography of the Columbia River basalts. Within the Columbia River basalts, there are many coulees, buttes, mesas, dry waterfalls, and hanging valleys attributed to the Great Spokane Flood. A coulee is a deep ravine which is carved out by great floods such as the Great Spokane Flood. Mesas are lone, isolated, flat-topped hills with very steep sides. And buttes are similar to these, except for they tend to be narrower than mesas are. And dry waterfalls are waterfalls that once had great amount of water, but now have none. A great example of this is Dry Falls in Washington.
Alright, so I have the geologic history of the Columbia River basalts. I'll start with the origin of these. It's kind of a 3-theory sort of thing. The first theory would be the Yellowstone hotspot, which you can see right here. Obviously, at one point they believe it was over where the basalts are right now, and right now it's where Yellowstone is. Another theory is the thinning of the continental lithosphere as a result of spreading behind the Cascade Arc, and also the proximity of the fissure vents to the tectonic boundary is the last theory. These basalts were deposited between 17.5 and 6 million years ago, cover an area of approximately 164,000 square kilometers. They occurred in 5 main episodes in western Idaho, central and southern Washington, and northern Oregon. The Imnaha basalt was deposited first, followed by the Picture Gorge, the Grande Ronde, the Wanapum, and the Saddle Mountains. And obviously these layers aren't drawn to scale or anything, but you can kind of get an idea of what the layers might be like. The Imnaha was first. At points it was 900 meters thick, filling paleo canyons, which you can see here is a kind of a rough drawing of it, but a canyon filled with basalt is what I would imagine that is. These were in the Clearwater River system. When it weathers, it becomes rounded and smooth. Next was the Picture Gorge basalt. This one was not very extensive, and they believe happened at the same time as the Grande Ronde, so from different sources. The Grande Ronde, however, accounts for 90% of all the basalt in the Columbia River basalts, deposited between 16.5 and 15.6 million years ago. It buried many of the older flows, and the massive amount of the basalt, the weight caused the crust to subside, forming the Columbia Embayment, which is the basalt-filled basin. The Grande Ronde flows originated in southeast Washington and northeast Oregon in the Chief Joseph Dike Swarm. Next was the Wanapum basalt. Only 5% of the total volume of the Columbia River basalts, but it overlapped much of the underlying Grande Ronde. This was deposited between 15.6 and 14.5 million years ago. The most recent event in the formation of the Columbia River basalts was the deposition of the Saddle Mountains basalt. It only accounts for 1% of the total volume, and this and the Wanapum were both very silica-rich, but this one was much more silica-rich and resulted in a lot of compression and extensional events deforming it. Around this time, according to paleogeometric data, the Imnaha basalt was deposited during a period of normal magnetic polarity, while the Picture Gorge basalt was being deposited at period transition occurred, and the data shows that a reversal occurred before the Grande Ronde was performed. Running across this area is, like in the western parts of it, is the Yakima Fold Belt. It formed 10.5 million years ago from north-south compression, has many narrow ridges made from anticlines, and broad valleys from the synclines. Also at this time there were 2 cooling patterns for the basalt. The first one that's theorized is the entablature jointing. This was what they called the top-down cooling, and it's very fine-grained basalt that's cooling in this jointing pattern. The other one was colonnade joining with the coarser basalt, and this is bottom-up cooling. When it comes to natural resources and hazards in the area, start with the natural resources being aquifer systems. Those are the only really natural resources currently, and they account for a lot of main sources for communities and agriculture in the area. There used to be a natural gas natural resource here, but it was found to be not productive at all. When it comes to hazards, there really aren't any because it's no longer being produced, so there really are no hazards at all. Thank you.